Uh, Hello everyone, good afternoon. Thanks for joining this session. Uh, we are from Michelin, India, and myself Amit, Sridhan and Sarang is going to present a talk harnessing GIS capability of Postgres using PostGIS and the OpenStreetMap data. We are just going to give you some brief overview of PostGIS, how and the various basic day-to-day use cases. It's a very vast topic, but we cannot cover the lot of things in the 35 minutes or the 40 minutes. So I'm just going to give the pause for a minute. Settle down. So we are just trying to cover some overview, high-level overview of the PostGIS, how the geometrical data is being used in the various database because of the advancement in the technology. For example, the routing data, the lot of apps like Zomato, Swiggy is using the geometrical data. It's now become a part of our day-to-day life activity. Okay. So now we are going to give you some basic use cases. Okay. So the scope of the presentation, if you can go back. So scope of the presentation is we are just going to give you a brief introduction of our Michelin mapping factory, what we do, introduction of our spatial data, the OpenStreetMap data, because we are going to use the OpenStreetMap data for our demo, okay, and some of the PostGIS functions and their uses, and ultimately we are going to show you some demo on the QGIS tool for the better analysis of the PostGIS data. Can you go to the next slide, please? Yeah. I would like to give you some brief introduction about a Michelin mapping factory, because when we say a Michelin, mostly the first thought comes to our mind is the tires and the manufacturing unit. But Michelin is also in the lot of other things. Okay, for example, the maps. Michelin is a first company which actually published the paper map way back in 1800 century. Okay, so it has a long relation with a Michelin like mapping domain. So our team mission is to build a geographical data platform and provide best-in-class services to support better and sustainable mobility in B2C and B2B customer. So as of now, all our customers are internal, but we are targeting external customers also. Okay. As of now, we also have a set of 50 professionals which are distributed across the globe, and it is a combination of a data engineer, geometricians, which are the map domain experts, as well as the data scientist, okay, and the business analyst. Our aim is to provide a platform which provides a cost-effective, sustainable, supplier-agnostic, geospatial SaaS platform to enable and accelerate Michelin mobility business. As of now, we are offering these solutions internally, but as I said, in the future it is possible that we offer this solution to the external customers also. Okay. Our domain expert lies in preparing a map data, preparing a routing data, preparing a search data, and also providing a geo-contextualization platform. I will explain you the geo-contextualization platform later in the presentation. Can you go? Now, before I go to the PostGIS, I just want to explain you what is a spatial data, what is a GIS data. So when we say a PostGIS data, it is geographical data or the spatial data. We say that lat long, any point which is located on our, let's say, nearby, it's a point lat long combination. We also sometimes say a point of interest. Okay. So point is nothing but a lat long. Lines is nothing but a set of points. So set of points makes a line. So lines is nothing but a set of points, and it can be a way or the road. It can be river. It can be a building layout. Okay. And finally the polygon. So all the geometrical data is mainly consists of these three types. Okay. Polygon. When I say polygon, it's like a state boundary, country boundary, district boundary, and all that. Okay. Now we understand what is a spatial data. There is a type or the categorization of the spatial data. It is mainly divided into the vector and the raster data. Okay, so vector data is nothing but, as I said, it's a point, line, polygon. When I say point, I also going to use a point of interest, POI. So it's a ATM. So ATM can be represented by a lat long on the map. Okay, so it is a point. Line is again, I said, road, it can be river. Okay, so all this comes under the vector data. What is a raster data? Raster data is a pixel data, and pixels, the combination of pixels makes a image, and each pixel has their own value. This value is mostly in the form of RGB. Okay, so raster data, one of the use case I can give you for the raster data, which we are also going to see, is deriving the altitude for a given location. Okay, this is just example. There are the multiple options, functionality of the raster data. What is the attribute data? When we combine the vector data along with a additional information. So when I said a point of interest is ATM, so what is the ATM name? Which bank name is that? Which bank it belongs to? You know, what is the building which belongs to? So these are all are attributable data combined with a vector data. What is a temporal data? It is a geographical information for a time. It is a geographical information for a weather station. So for example, for a given location, the weather data is also considered as a time series data. Okay, every day, every hour it changes. So these data can be also classified as temporal data. And yes, we can come here. Now, what is a PostGIS? So most of us are aware of a capability of the Postgres database. It's an industry standard database widely used. PostGIS is an extension which allow us to store the geographical data and do the operations on it. You can manipulate the data, you know, lot of manipulations, lot of functionalities are present in the PostGIS. So we have to enable this extension to use this functionality. Now the PostGIS data, the PostGIS extension is widely used, industry standard. It become a de facto industry standard. Okay, it is also in 2006. It is also approved by the Open Geographical Control Standard and of the compatibility. Okay, and if we just go to the history, like it is how the PostGIS is started. It started in 2001 with a 0.0 version. Okay, and over the period of time, it matured as a industry standard de facto option to store and play around the geometrical data. Now in the 2024, it is a version 3.5. It came long way from the 0.1 to 3.5 version. Okay. Now why this is the PostGIS? Why the PostGIS is easy for us? Because PostGIS, anyone who know the basic SQL can easily graduate from like SQL to the PostGIS functionality. It is as simple as writing the simple SQL using a PostGIS functions. Okay. Also, it is a very it has a rich functionality to do a simple to the complex operations. Okay. It also support. It is very well integrated with various tools like QGIS or the ArcGIS. Okay. And it has a rich capability of doing a joins, buffer, and distance calculations. Okay. So we are going to cover basic functionality using a PostGIS function, and we are going to use the post query tool. Okay, using a OSM data. Now just a brief introduction about a OSM data. What is OSM data? It's a OSM data is nothing but a data by the community, or we can consider it as a Wikipedia of a map. Okay, it is by the community for the community. Okay, it is a very big community, more than 10 million users, active users who are contributing to the OpenStreetMap, and lot of edits, millions of edits is happening on a daily basis. So if any of you are interested, there is a OSM India group, OSM India chapter here in the Bangalore and the Delhi. They are actively working on the enhancing the coverage of the OSM data in the India. So if anyone wants to join them, they can explore the OSM India. It is available on the Twitter, also on the wiki page. Now, as I said, we are going to use a OSM data. Where to get the OSM data? So there are the two major options are there. One is a GeoFabric data and one is a Planet OSM data. So if you see the GeoFabric data, we have a download option. We are going to use the India data. We have already downloaded the India data, and to speed up our process, you know, we are going to focus on the Bangalore data. Now, so we understand what is OSM. We downloaded the OSM file. We want to load the OSM data into the database. Okay, how to do that? So we'll create a database, we'll enable the extension, and we will load the data. So we are going to create a database. Yeah.
Page is stuck. Just
okay. So we are going to create a database, and we are going to enable the extensions, the PostGIS extension. For that purpose, you have to download the PostGIS extension. You have to install it on your machine or your VM. Okay, and then we are going to load the data. So this is just a demo one. Is our database got created. Now we are going to enable the extension. Okay, so yes, so we'll enable the extension. We'll switch to the database demo one. And this the second extension is the HStore extension, which is nothing but to store your key value pair. Okay, it is used to fetch the information from the OSM. Okay, now both the extension are created. Now if you maximize this, if you see, this is a command we actually prepared, and it has a information about your database, like the local host, port, username, and all that, and the to which database that we want to load the data. So here we have given a demo one, okay, and the PDF file and the style file. So style file is nothing but a sort of configuration, which information, because OSM has a lot of value, lot of information. It is a sort of configuration file which controls like what information to be loaded in your database. Okay, we'll show you like how this works. Okay, now there are the other options also. For example, the -j is for multi-threading, -c is for caching. Like if you have a large value of the RAM, you can use the maximum possible value of the RAM and all that. Okay, so if you can, yeah. So if you see, the data is getting loaded. Now if you see the planet, OSM, point, line, these are the tables getting created. Okay, and we are going to explore these tables also. It is going to take around 30 seconds. Okay, so this PBF data we have downloaded, like we have downloaded the India data, but we clipped the Bangalore data to speed up the process. Okay, and see, this process is getting completed and the indexes are getting created. Is it over? And if we see, this is the flow, like I explained that we have created a we have the Postgres, we have created a database, we have downloaded the OSM data. We have used the OSM to PGSQL, and these are the tables which is getting created. They're the OSM lines, polygon, relations, nodes, and all that. Okay, Shidan, if you can switch to the demo one. Yeah. So we can see these tables are got created. Okay, now we have little bit understanding of PostGIS, like you know. OSM, we have downloaded the data is loaded into my database. How this data looks basically. Okay, so to our naked eye, like how it looks. So we have multiple options to look at this geographical data. One is in the binary format, one is a well-known text, another is a GeoJSON format. Okay, so we'll just do a query and we'll see how the data looks. So we have taken 100 records from the point table. Now you see the st as text. St as text is a function of a PostGIS. If you do not have the PostGIS extension, this function will not work. Similarly, st. So all functions of the PostGIS start with a st underscore something. This is a st as a GeoJSON. So if you look at, I think it is readable, not readable. Okay, so if you look, this is the as text output. This is a as text, and you can read it. So it's nothing but a lat long of that point. If you look at this part, GeoJSON, it's a something very similar to the JSON storing, JSON format, okay, but it's a geographical data, we call it as a GeoJSON, okay, and this is a binary data, it is not readable basically, okay. Now we are going to use some basic day-to-day activities that we using the PostGIS functions. So first example is, let's say you have the OSM data or the geographical data, and your requirement is to find the area of each polygon or area of each administrative area. Okay, it can be village, it can be city, it can be state. So if here we have used the ST function, okay, and we have converted the geometry into the geography because we wanted to have the this area in a square per kilometer. Otherwise, it will be in the geometric degree. The output will be in the degree. Okay. So if you can see, we have used the ST area function, and we can have the output of the as the area. Okay. So it's a common requirement which comes to our day-to-day if you deal with GIS data. Second example I am going to take is, like as a use case, I want to fetch the wards of a Bangalore municipality. Okay. So for example, this OSM ID is for the Bangalore municipality, okay, and I want to find what are the wards of the municipality. If you can execute, okay, so you can see the output, south zone, east zone, and all that. So these are the 10 zones which are part of the municipality. Again, disclaimer, it is all based on the OSM data. It may not be complete data, okay. So it is possible that there may be a mismatch sort of thing, okay. Now if you can, yeah, how it looks, yes. So you see this first, the big polygon is this one, OSM ID, the Bangalore municipality, but if you see the smaller polygons inside it are the wards of the polygon. So again, the focus is on the ST contains. ST contain function is nothing but a set operation of A completely belongs to B. So our small wards is completely part of a bigger ward or the bigger polygon, which is a Bangalore municipality. So this is again a common requirement which we want to, let's say requirement can be the list on all the district of a particular state. Okay, so you can use the ST contain function. We will move to the next part. We will extend this functionality for finding the total number of schools in each of the ward. So if your requirement is to list down all the schools, so school is just example, it can be anything else, hospitals, it can be ATMs, banks, anything. But for this purpose, what we want to do, we want to find the number of schools in each ward of the Bangalore municipality. So we have used the ST contains again in the previous slide. The new function here is ST intersection. ST intersection meaning the point is belonging to the polygon or not, the smaller polygon, the ward polygon. So output is like, again, the east zone has this number of schools and all that. The new functionality that we came across is a ST intersection, okay, and the basic SQLs like sum and count, all that. Next example is ST length. So again, one of the common requirements that we get is like, what is the total length of the road or total length of a river, okay, any geometry. So in this example, we are trying to find what is the total length of the road based on the highway type. So highway, when I say highway in OSM, highway can be state highway, national highway, residential the road which is in between the residential, service road and all that. So if we execute using the this query and the function that ST length we are using, we'll get the length of the road category wise. So for example, the residential has the highest number of kilometers, okay, but the focus is on the ST length. The ST length, we can use it for the other cases also. Yeah, this is a example. Now let's say we have a hospital or a school and we want to create a no horn zone, okay, or it can be also used for a case like government can use, do not issue a liquor license near to the school. So function is ST buffer. So you have the point and you want to let's say no horn zone, you want to apply this rule, no horn zone in a 500 meters, okay, or maybe 1 kilometer. You can change the parameter. So this is the ST buffer. Around a point, around a line, you are creating a buffer. Okay, and you can use this for implement your policies. Next example is finding a, let's say the restaurants near to the PG conference location. We have hard coded the lat long point. This is a lat long or the long lat point for, and we are using a ST make point. So ST make point is another function which is used to create a point from a given lat long. Okay, so we have used the ST make point, and our requirement is to find a restaurant around our PG conference location, and we have given some filters here. Okay, so important point is STD within. So this is another function which is like finding a area of interest or the points in a given range. So for example, my point center point is this one, ST make point. Okay, and within the 5 kilometer of this point, I want to find a restaurant of my liking. I can use this part. Okay, ST make point is a new function which I am introducing here. Okay, make point and the distance within. Sorry. As I said that we also have a raster data type, which is used for the multiple purpose, but we are going to use it for the finding the elevation. Okay, so if you look, the raster file looks like this. Okay, if it is a higher in the altitude, you can see the difference. These are the higher, and on the plane, on the ground, it will be not edged or the not roughed one. So ST value is a function. ST value is a function, and again we are creating a point from the lat long. Okay, this is for the point for the lay, and we are using ST function, ST value to find the altitude. If you can execute, okay. So you can see for this the altitude is 2492. Okay, and similarly the another example is for the OT. Okay, so for the OT, somewhere in the OT or near to the OT, 2262. Okay, so these are some basic functions that we actually uses in our day-to-day life. Okay, our regular use cases. Now I am going to hand over the presentation to Sridhan, where he is going to use the QGIS and showcase how the geometrical data can be analyzed in the QGIS tool for the better understanding, because holding the data in the database is not going to serve our purpose. We need tools or options to analyze that data. Okay, so Sridhan, up to you.
Okay, thank you, Amit. So we'll be seeing two different demos. First is related to OSM Insights POI mapping. So as Amit said, and as we discussed about different special functions in PostGIS, so we'll see how to visualize in QGIS, how to visualize data in QGIS. So as we discussed, we download the data from GeoFabric. We clip it using Osmium, and after that we need to extract that data. So data is extracted using the different parameter, using the coordinates, and there will be output file which will be again in the PBF format. Further, we'll be seeing now, we'll check in QGIS that how to visualize that. So the first, okay, so this is a QGIS, and maybe most of you have used, or it's quite an interactive tool for visualizing any geometry. So what we'll do is we'll take the hospital and school. I'll show you that how this data is particularly extracted. So this is the hospitals in Bangalore, and okay, so next what we'll do is so now this particular data we have added via database. So there is a provision in QGIS to add data from PostGIS, and we can add our own if it is a cloud server or if it is a local. Currently it's a local, so that is something which you can do. It's quite interactive again, and not only from like database, we can also add from the external source. So if you could see this, So I'll just decrease opacity. Okay, so now what exactly we are seeing is in the demo we are identified one coordinate, and from that point we'll be seeing different distances, like from that point like in 1 kilometer how much schools are there, in 3 kilometer how much schools are there, and 5 kilometer and so on. So so there again okay, we'll just load the style file. So style file is nothing but you can save the style of your existing project. And so now here you can see we have taken one example of Indiranagar, one point in Indiranagar, and this pink as you can see, this is categorized in different distances. So here this particular pink represent the schools in 1 kilometer, then it's a 3 kilometer, 5 kilometer and 10 kilometer and beyond. So if I could show you like how this particular data is extracted from already downloaded or already uploaded data. Like we saw that we have uploaded data from PBF file and in the different tables, point, line, polygon table. So there is a tag, it's called like, so there is a tag information assigned to each point or each line or each attribute. So this is the hospital tag, which is added for all the points, and that's based on that we can extract the data using the so this particular is the HStore, and based on the query, based on the simple query, in fact we can directly extract the hospitals or the schools. So this is about the hospital. We have one more example for school. So for school we have taken the center Bangalore center, and from there how many schools are there in the proximity. So that's what we are checking here. So as you can see, so here you can have multiple, like you can automate your process with different tools. For if you are using some Jenkins, or if you are using on the cloud solution, if you have any pipelines, you can write down all the queries and you can execute in a simple pipeline where you can extract the data, you can save that data. In fact, here it is added in the school includes the colleges, it includes the different institutes, trusts. So further you can derive it, so further you can segregate, or in fact you can check like only if you want college, if you want school, so that based on that you can categorize that. Okay, so this is about the POI. So next demo will go so there is so related to PG routing. So you know the routing, so when we calculate from point A to point B, if you want to go, so we know that in Google we mostly use to go from point A to point B. So the behind that particular calculation, there is always, there are different algorithms. So we will take here a simple algorithm called Dijkstra. So Dijkstra is a shortest path finding algorithm. So before that, so PG routing is extend the PostGIS capability in network routing, and it's enable the shortest path and for route optimization. So PG Dijkstra is a basic algorithm which is used to identify the least cost route between two routes. So when we are calculating routes, we always need to have connected routes. So the routes are connected. So I'll give you the example, like when you are going from point A to point B, you always see that it always finding the shortest path. It always going near the motorway, near the high level way, because the graph, when we run the particular routing process, we allocate the weights to each route. So if there is a motorway, it has a very lower weight, and if it's a local route, there is a higher weight. So based on that, when we calculate a route, a graph identifies that okay, I have to go from the lowest weight, wherever it is available, and based on that the route is formed. So that's the same thing it is happening here, but we were using the Dijkstra algorithm. There are quite advanced algorithm in the routing. Okay, so I'll just show you that. So for example, we have taken the data in the Luxembourg. Okay, so this is the line data which we just have loaded, and it's from Luxembourg in fact. So this is the Luxembourg line data, and in that we are calculating route from point A to point B. So the itinerary is calculated is from Rue Denis Netgen to on the A3 highway in Luxembourg. So I'll just show you. Okay. So this is the PG Dixta, and based on the so this is particular table you can connect, or you can check like how the PG Dixta or PGI Dixta can be used. You can download any data from OSM and create your own routing algorithm, which is yes. So here we have just okay, it is not zooming to that, but
maybe you can close the PG admin and execute it again.
Yeah, so this is what the route looks like from calculating from point A to point B. So here the node what we have selected is calculating from 10 to 800. So we identified that the first route what we have taken, the itinerary, the first route identifies as a 10. This you can do with your simple calculations, like again you can use the different queries, different special queries, that what is the nearest node of the of that particular route, and based on that this value can be filled, and this is how the route is calculated. So further we'll go next. Okay, so for the application of GIS with PostGIS and OSM, there are quite a lot, and so you can use it in the identifying the driving patterns, mobility trends. So you can use for the intelligence gathering, you can use for admin boundary generation, and obviously for web map and GIS application there are quite a lot companies which are using the OpenStreet. Next is what Michelin is doing in how Michelin is using it. So we are coming with two use case, or so the first one is map matching. So you can see here this first image. In this particular image you can see that it involves the process of matching GPS points to the closest road segment in the digital map, and which enable accurate positioning of the points of road network. And second is the contextualization. So this is a process of enriching the data. If you have existing data, you can enrich with adding the road network, the contextual information to it related to special data or semantic information, which improves the decision making in mobility, transportation and logistics. So as Amit said at the start, so we are not just about tires, because you might be knowing Michelin is widely known as the high quality tire or premium tire company, but we are now deeply invested in digital solution and software driven innovations. So now we call it as expanding beyond tires, and so there is a lot to see in the digital services. We are leveraging data, AI, and different software solution, adding the mobility solutions, fleet management and road safety. And the company are actually actively involved in the connected mobility, predictive analytics, intelligent transport system impact. And as you can see, these are different services which are provided, digital services which are provided by Michelin. Okay, thank you all. And if you have any questions, doubts, you can.
I hope you got some basic overview of the PostGIS. Yes, please.
Like if you want to show the itinerary of the logistic vehicle from point A to point B, you don't want to show the exact points, but you just want to summarize this is the cities it has traveled.
Okay.
Is there any option in this?
Yes.
You can show the high level points.
Yes. So as one of the slide that which Shidan has shown us is the contextualization part, correct? Now you have let's say you have the raw GPS data which is being generated from, let's say, a trip from Delhi to Pune or the Delhi to Bangalore. Okay, you have a raw GPS data. What we do, we take that GPS data. There is a service called as OSRM, Open Search Routing Machine. Okay, we send this data the GPS data to that services, it gives us a match nodes. So when I say match nodes or the match points, it's a nodes or the points on the road. So this yellow lines is a raw data, blue lines is a match nodes. Now we got the nodes, meaning that we now we map the trip on the road from the Delhi to Bangalore. Now for each node there is a different information is available. For example, this node is going through which city, what is the altitude for the particular node, what is the road surface, is it a cement road, it is a tar road, you know, it is going through urban area, rural area, is it going through the state highway, national highway, and all that. So the question that you mentioned, like for the whole trip we can also the speed limit. Okay, so if the particular speed limit is 60 kilometers, but your vehicle is driving at 80 kilometers, it will also flag that. So this is one of the common requirements by the truck owners, basically, where they want to understand or analyze the trip. Okay, and because in the European or the Western countries the fines are very heavy, here also now the fines are very heavy, correct. So as a fleet owner, they are very specific if they are not going into the, if they are breaking the speed limit or going into the no entry zone, like that, correct. So using this service, then in fact this whole platform is for the same requirement, where we want to do the analysis of the whole trip, and this data is given to the another team, maybe let's say the data scientists. They try to understand the pattern. Okay, this can be also useful to identify the accident hotspot, or a particular location where lot of people are applying a hard brake, or for example it can also use for identifying a dangerous curve. For example, you have a straight road, but suddenly the curves comes out. So this is the same. Now if you see like the same question, so it categorize, it give you the whole information about the road category. So let's say the 40% of your journey is on the national highway, 30% in the state highway, rest and on a service road and all that. Where it is going to the city, village, all that. What is the slope information? Okay, safe driving split. So these are the just five contexts, but there are a lot. For example, what is a road number, what is a road name, lot of things. Yeah.
So we have a use case where we need to repeatedly check if a location is in a geofence or not, and we do it in a batched manner, 1,000 locations at a time. So we have noticed PostGIS serves well when the polygon is smaller, but it suffers when we have large GeoJSON files.
So for this you can use a ST subdivide function. So what it do is, let's say I will take a school example. Let's say your requirement is to find the total number of schools in each state of India. Now each state is a larger polygon. What we can do is we can divide the larger polygon into the smaller polygon using a ST subdivide function. What it do? It divides your polygon in a smaller piece. If you apply the same query on a smaller polygon using ST subdivides, result will be very fast.
So will that basically break down single row into multiple rows? Or
yes, no. So ST subdivide breaks the bigger polygon into the smaller polygons, but you don't have to do it manually. ST subdivide will take care of it, but the result is 10 times fast. We have experienced the same thing. It is yes.
Is there a threshold like 10 kilometers?
Size of polygon.
Yeah, size of polygon. 10 kilometers, 20 kilometers.
I think you can understand by doing a trial and error, because it's like so ST subdivide function has another option, like in how many smaller polygon you want to divide the area. So if it is a fairly large area, for example Maharashtra or Karnataka, you can divide it into the 100 part sort of. But if it is a district part, you can maybe do it with let's say the 10 option.
Like if you tune your you can check very much bigger polygon also, but the chances will be decided by you. So if you are working on India polygon, then you will define definitely some bigger polygon, bigger subset. But if you are working with a small subset, then you can define as per your precision, as per your need, what exactly you are taking. Suppose you are
Postgres version from 13 to 17.
I think PostGIS version works separately, but if we are doing major version